nuclear transport receptors bind to a cargo's nuclear export signal or nuclear localization signal, both of which come in various shapes and sizes. There's a lot of nuclear transport receptors. We know about 35 of them right now. In the future, we might know more. But the nuclear transport receptors will bind to a cargo's nuclear export signal or nuclear localization signal and escort the whole thing across the nuclear pore complex. So there's two kinds that I wanted to talk about. The first one will be the nuclear import receptor, just on its own. It'll bind to the nuclear localization site of a cargo protein. And while nuclear import receptors are all very unique, cargo proteins also have their own preferences. And despite the fact that they have preferences, it doesn't really matter. It's kind of redundant because in the end, whatever nuclear import receptor is available will be the one to do the job. So nuclear import receptors have this hierarchy where, since they're all competing to do their job properly, some will have more privilege over others, over crossing the nuclear pore complex. And that'll be dependent on their concentration and the affinity for FG repeats. Nuclear import receptors have a spiral staircase, and they're all alpha helices on the inside, and they have heat repeats which bind to FG repeats. So this is kind of what it looks like on the inside. It's really groovy, which means all these little purple alpha helices have these little hydrophobic pockets on the sides, which the FG repeats will bind to. So looking at this little black square, we're going to zoom it out. And again, the purple is the alpha helices, and the light green will be phenylalanine, which is a hydrophobic amino acid, and the R just the rest of the molecule. And so between the hydrophobic pocket and the hydrophobic phenylalanine, you'll have van der Waals interactions. And it'll just stick right in. The other kind of nuclear transport receptor that I wanted to talk about was, it's more fancy. It's pretty much the last one, but more fancy. It'll be a nuclear import receptor attached to a nuclear import adapter, and then the nuclear import adapter will attach to the nuclear localization signal or the nuclear export signal of the cargo protein. So the nuclear import adapter is pretty much like the dongle that you would attach to your new iPhone if you had the old headphones, the circle headphone jack, versus like the new iPhone where you can't really put it in. So you'll need this adapter to basically just enhance the amount of cargo proteins which it can attach to. So say that the nuclear import receptor can only attach to like 5 different cargo proteins. When you add the adapter, maybe it'll go up to like 100 cargo proteins. But they'll have to be similar to the original cargo protein.